In nature, we often see pattern that retain the same structure as it expand outwards. And the same things in mathematics, we will see patterns that basically are the same as it extend infinitely. But in mathematics, we do verify them. For example, at the first two integers, at the first three integers 9, at the first four 16, and then at the first 5 will be 5 squared, at the first 6 squared. So we conjecture that the sum of the first n is n squared. And writing mathematics, we notice that the nth odd number is 2n minus 1. So in mathematics, that's what it looks like. The sum is this 1 plus 3 up to the nth odd number. It should be n squared. We want to prove that. We can view these statements as each one individually as infinitely many statements on a list, and our job is check the sum of one odd numbers 1 square, which is true, sum of two odd numbers 2 square, and so on, so on. We want to check every one. So let's start. Okay, how can we verify every one of them is true? Let's start checking. First one is true. Sum of two odd numbers 4, 2 squared. Sum of three odd numbers 3 squared. So let's suppose we check up to the kth one. Okay. Then the next one we want to check is this one. If I add one more numbers to these, in the next one, should I get k plus 1 squared? Here's the inductive argument says, okay, to do that, one way to do this, is we fold that the things we already confirmed into the one we yet to confirm it. Here's what I mean. Here's the sum with the up to k plus 1. Notice the from part is already checked. We add up to the k squared. So I replace it by k squared, add to the back part, I get k plus 1 squared. Therefore, I use the from one to confirm the one following the next one. These is like dominoes. And how do I make all these dominoes fall over? I knock over the first one and make sure every domino will knock over the next one. Therefore, every one of them is knocked over, or every one of these statements is true. For example, I can use this for this inequality. Check the first case is true when n0 reset is true. Then assume the case k equal to k. Then we want to prove for next case at k plus 1. So this is a case for k plus 1. And we'll use the part that we already know, this bigger than that, so we can follow the inequality and easily confirm this. Okay, and that's it. Bye-bye.